Every time you enjoy the sun today, you are actually enjoying a survivor that escaped 200,000 years ago. Scientists are most afraid not of this number itself, but of what they have discovered by doing some calculations. The speed of light might not be a blessing for humans after all, but a hidden prison from the cosmos. In the next few days, I'll show you how the world works. I'll explain why sitting quietly on your sofa is actually a supersonic sprint. Why the speed of light isn't just the pace of light but a rigid constraint of spacetime. And whether humanity might ever escape this vast prison through wormholes or warp engines. By the time you've finished this part, you'll understand the secrets of Einstein's relativity and think differently about time, space, and how things happen. You'll even understand why the speed of light limit actually protects our universe from collapse. This will be the most mind-blowing cosmic truth you'll hear this year. To understand this, we must first examine the element trapped within the sun's core. This is a force that has struggled for 200,000 years without fully escaping: light. Light is the fastest thing in the universe. It travels through a vacuum at 300,000 kilometers per second. It makes sense that traveling the few 100,000 kilometers from the sun's core to its surface should be a really quick journey. But in the sun's core, it's trapped and moves outward at an average speed of just 3.5 kilometers every year. This is 1,000 times slower than a snail's pace. Picture a bullet going really fast, hitting a huge jelly. It would get stuck in a quagmire, even though it was moving really fast. By the time it finally reaches the surface after a very long time and shoots into space, Earth's dinosaurs will have been extinct for a very long time. This makes me feel unhappy. But the truly scary truth that scares scientists is even further ahead. Imagine you had a spaceship that could travel at the speed of light. It would take 50,000 years to travel from Earth to the edge of the Milky Way, which is much longer than a person's life expectancy of 100 years. This means you would have lived and died 500 times on the spacecraft before we even left our solar system. This made NASA researchers silent for a long time when they saw the calculations in 2019. Everyone realized something very difficult. The speed of light is so fast that it's impossible for human bodies to travel between galaxies. Even if we wanted to, it would take 1 billion years to colonize the Milky Way. But the sun will only last for about 5 billion more. However, physicists later discovered that this seemingly unreasonable physical rule might not be meant to restrict human expansion at all, but rather to protect some deeper cosmic law. If this law were broken, the whole order of the universe as we know it would collapse instantly. Don't lose hope just yet. You're about to discover an even more astonishing truth: the illusion of speed. You might think you're sitting quietly on your couch at home, scrolling through videos, and your body is completely still. But when we look at the bigger picture, things are different. At this very moment, you're going at 1,674 kilometers per hour. That's twice the speed of a Boeing jet and is just the basic speed given by Earth's rotation. If you are standing on the equator, it feels like you are on a very fast-spinning merry-go-round, changing position all the time. But that's just the start. At the same time, Earth goes around the sun at 30 kilometers per second. That's so fast that in the blink of an eye, you could fly from Beijing to Shanghai. But that's not all. The whole solar system is speeding around the center of the Milky Way galaxy at 230 kilometers per second. And the galaxy itself isn't sitting still either. It's speeding towards a mysterious area of space that scientists call the Great Attractor at 550 kilometers per second. This place looks like a huge gravitational hole in space that is pulling millions of nearby galaxies towards it. In other words, you are going 550 kilometers per second. That is 1,500 times faster than a bullet leaving the barrel. But as a passenger, you won't know about this. This amazing thing has led scientists to ask a very important question: if we can travel so fast, what else in the universe can travel even faster? The obvious answer is light, but most people don't understand how amazing light really is. As early as 1990, CERN conducted an interesting experiment where they tried to pass light through ordinary granulated sugar. The amazing result was that in this medium, the speed of light dropped to 200,000 kilometers per second, 1/3 slower than its normal speed in a vacuum. This means that light is never in its final state, no matter what the conditions are. It slows down a lot when it passes through different materials. It's like a champion racehorse running through water that's up to its waist, with its movements becoming slow and heavy. In 2001, Linao Hao, a physicist at Harvard, achieved an even more astonishing feat. He used a very complex technique to slow light down to 60 kilometers per hour. This is slower than the speed limit on urban highways. She did this by trapping light inside a cloud of atoms that had been cooled to a very low temperature, which made the light almost stop moving, as if it was stuck in mud. This was a big deal for the physics community because it showed that the speed of light isn't set in stone. It can be changed by humans. But this makes us wonder something even more important. Why does light move at all? This might seem like a simple question, but it's more complex than it seems. For example, raindrops fall because Earth's gravity pulls them down. The Earth goes around the sun because of universal gravitation, and humans walk by pushing off the ground with their legs. But what makes light move? It has no rest mass, no legs to push it, and not even an initial push at the moment it was created. But it reaches its fastest speed straight away. This question confused physicists all over the world for hundreds of years. Then, a really amazing truth was discovered. Light doesn't need a reason to move. Light is made up of electromagnetic waves, which are basically continuous conversions and mutual propulsions of electric and magnetic fields forming waves in space. Although this explanation sounds scientific, if you think about it, something doesn't add up. We usually think that waves need something to carry them and make them travel. For example, water waves travel through water, sound waves travel through air or solids, and vibrations along a string need the string itself to carry them. So, we need to know what kind of material light can travel through. To explain this, 19th century scientists came up with a famous idea called the ether. They thought that the universe was filled with a substance that you could not see or touch, and that light traveled through this substance, which was called the ether. In 1887, two American scientists, Michelson and Morley, designed an experiment to prove that this substance existed. Their logic was simple yet clever, since Earth moves really fast through space. If there was really air all around us, Earth would be swimming through air. So, the speed of light should be a little different depending on whether it is traveling with or against the flow of this ether. But when the results came in, both men were stunned. The data showed that the speed of light was the same in every direction, with no measurable deviation. This was a really big discovery at the time, because it meant that the ether, which people had been looking for a long time, probably didn't exist. Light spread without needing anything to carry it. This was a huge discovery. Just like finding out that fish could swim freely in a place with absolutely no water. This result was hard to understand, but the scientific facts showed it was true. Scientists who study light physicists had to accept that light is a wave that travels without needing a medium. This means that light can travel through a universe that has no matter in it. This was the first time that something unusual happened with the light. The second, even more mysterious question that followed was, whose speed is the speed of light? You might think this is a strange question, but the speed of light is a property of light itself. But this answer isn't completely right. Light speed isn't the only thing that light can do. In 2016, scientists detected gravitational waves. These are ripples in spacetime caused by massive celestial bodies moving around very quickly. Amazingly, these waves travel at exactly 300,000 kilometers per second, the same as light speed. By 2019, scientists had discovered that neutrinos also travel at speeds close to the speed of light, with only very small differences. Even gluons, the particles responsible for transmitting the strong nuclear force, travel at the speed of light. This evidence leads us to a big conclusion. The the speed of light is not the only property of light. It is basically the underlying speed limit of spacetime itself, a line of basic instructions, written into the logic that governs how the universe works. We call it the speed of light because it was the first thing that scientists measured. If we had measured gravitational waves first, textbooks might say that their speed is the speed of gravitational waves. So how did humanity gradually find out about this speed limit that decides whether the universe will survive? The story starts in 1676, when Danish astronomer Tycho Brahe saw something strange while studying Jupiter's moons. It makes sense that the time it takes Jupiter's moon Io to go around the planet should stay the same. However, when he measured it himself, he found that the period was sometimes shortened and sometimes lengthened, with errors adding up to as much as 22 minutes. Brahe thought about this for a long time before suddenly understanding the mystery. This wasn't a problem with Jupiter's moon at all, but rather the time it takes for light to travel. When Earth was closer to Jupiter, light traveled the distance more quickly, making Io appear to rotate more rapidly. On the other hand, when Earth moved farther from Jupiter, light had to travel hundreds of millions of extra kilometers, which made Io seem to rotate more slowly. By using this clever method, Raymer was able to calculate the approximate value of the speed of light for the first time. His result of about 220,000 kilometers per second was not the true value. But it was the first time people realized that light does not arrive instantly, it has a speed that is very fast but not infinite. But measuring the speed of light was still very difficult. In 1983, the General Conference on Weights and Measures made a very important decision. They decided that the speed of light would always be exactly 299,792,458 meters per second. It's important to note that this figure wasn't measured, it was defined. From that point, the speed of light was no longer something that had to be measured many times to check it. It became an absolute standard. Scientists then used this speed of light to define the unit of length, the meter. This is the distance light travels in that tiny fraction of a second. This operation effectively told the world that the speed of light was now impossible to measure more accurately. To measure how fast light travels, you need to know the distance first. But the distance is defined by the speed of light, which makes it a never-ending set of questions. It's like trying to measure your own height with a ruler that is set by your own height. You'd probably think you are the same height as yourself. This strange situation happens because light speed is not an ordinary speed. It actually shows the underlying structure of space and time. In 1905, Einstein published his revolutionary theory of relativity, which completely changed how humanity understood the world. He made a very strange argument. The speed of light stays the same no matter how you measure it. No matter where you are or what you're doing, the speed of light will always be the same. It's 300,000 kilometers per second, no more and no less. This sounds ridiculous, but over the next 100 years, lots of careful experiments in physics showed that Einstein was right. In 2016, scientists accelerated subatomic particles to 99.9999991% of the speed of light within the Large Hadron Collider. They then caused these particles, moving very quickly, to emit photons. What happened? These particles were still traveling at the normal speed of light, and their speed at the start had no effect on their speed afterwards. This goes against what we see every day. If you throw a ball forward on a high-speed train going at 200 kilometers per hour, the ball will be moving faster than the train, but not by much. But in the world of light, this rule of addition doesn't work. No matter how you change it, light will always travel at the same speed. This property shows us something even more amazing: time is relative. To check this, the Chinese Academy of Sciences did an important experiment in 2017. They put two atomic clocks on the ground and in an aircraft that was flying for a long time. After the plane flew at 10,000 meters for 15 hours and then landed, the researchers compared the two clocks. They discovered that the one on the aircraft had slowed down by a few tens of nanoseconds compared to the clock on the ground. This was not a problem with the clock itself. It was a way of showing that time slows down when something is moving very quickly. When something moves very quickly, time seems to go even more slowly. This is called time dilation. Imagine there are two twin brothers. The older brother stays on Earth and lives a normal life. The younger brother gets on a spaceship that travels at almost the speed of light to explore other stars. Life on the spacecraft continues as normal for the younger brother, who feels like only 5 years have passed. But when he returned to Earth, he was amazed to see that his brother, who had stayed behind, had turned into an 80-year-old man. This might sound like something from a sci-fi movie, but it's an irrefutable law of physics, a scientific fact that has been proven over and over again through experiments. What's even more surprising is that if the spacecraft really did reach light speed, the younger brother's time would stop completely. For him, traveling through the whole universe might take an instant, but when he stops, the outside universe could have advanced thousands or even tens of thousands of years. This feeling of being able to manipulate time is one of the most important secrets that light speed reveals. Light speed is amazing, so why can't we break through this barrier? The answer is in how heavy the object is. Einstein's famous equation shows that the faster an object moves, the more mass it has. As an object speeds up to approach the speed of light, its mass becomes bigger and bigger. This creates a problem that can't be solved. To make a really big object go really fast, you would need infinite energy. As early as 1935, Einstein and his colleague Rosen suggested that black holes might be connected by a special bridge, forming a very short cut through spacetime. Later, physicists discovered that these wormholes do not need to rely on massive black holes. They can potentially appear anywhere at the microscopic quantum level. However, their size is tiny compared to atoms, so they can't hold macroscopic objects. In 2019, a research team at Caltech used a quantum computer to simulate a basic form of a wormhole. This was a very important moment for science, even if it only lasted a few nanoseconds. Imagine taking a sheet of white paper and marking one end with Earth and the other with Alpha Centauri, which is several light years away. But if you fold the paper in half, aligning the 2 points, then poke a hole through it with a pencil, you can reach your destination by moving just a few millimeters. This is the main idea behind wormholes. They don't let you travel faster than light, but instead change the very fabric of space, pulling distant points together. The second approach is even more daring and exciting, the warp drive. In 1994, Mexican physicist Kublai came up with an idea that could change the future of humanity. He thought that if we could create a special engine that made space in front of a spacecraft collapse and get smaller, and made space behind it get bigger really fast, the spacecraft could move forward on these spatial waves like a surfer riding a wave. The clever thing about this process is that the spacecraft itself doesn't move at all when you look at it. What truly moves is space itself. Because space can expand and contract independently of the speed of light, this method of travel does not break the laws of relativity. This means that, in theory, humans could be able to move faster than light. In 2015, NASA even set up a secret research team to work on this. They found that while the idea seems mathematically perfect, it's not realistic to use in practice. To warp space, you need a substance with a negative mass and negative pressure. This is a mysterious thing that we have never truly discovered in the real world. It's like having the perfect plan for a palace, but not having the special materials needed to build it. In 2021, physicists suggested using the Casimir effect to create tiny amounts of negative energy, but it would still require a lot of energy. For example, it would be like converting all the matter of Jupiter into energy to send a spaceship just 1 light-year away. Even if we assume wormholes and warp drives become reality in the distant future, humanity would still face a big philosophical and physical problem: the limits of causality. In 2020, scientists at Oxford University did some very complicated maths. They found that if humans ever traveled faster than light, we would definitely see things that happened in the past. This is because the speed of light isn't just a speed limit. It's the fastest possible speed for information to travel. The sun you see when you look up now is actually the sun from 8 minutes ago. Because sunlight takes 8 minutes to reach Earth, the stars you can see in the distance might look the same as they did hundreds or even thousands of years ago. If you could instantly teleport to a galaxy several light years away and then look back at Earth through a very big telescope, you would see yourself doing things from years past. This sounds amazing, but it also creates a big problem. Could time travel completely change how the universe works? If the future could affect the past, and if one thing could cause another, then the way the universe works would be completely chaotic. By 2023, more and more physicists started thinking that the speed of light limit itself is a protection built into the universe to keep the law of causality. It makes sure that time can only go in one direction, meaning that every event in the universe has a starting point that can be traced, and it stops logical dead loops. If you look at it this way, the speed of light is not something that the universe puts on us. It's the basic way that the cosmos works. This law is very important because it helps us to understand the past and the future. It makes sure that everything in the universe always stays the same and that the laws of physics don't just suddenly stop working one day. Without the speed of light, the whole universe might become a chaotic mix of past, present, and future. If things weren't connected in a certain way, they wouldn't be able to form any kind of pattern. So, the speed of light is more like a way for the universe to protect itself, making sure that our world remains logical. It's amazing that even though the speed of light limits how far we can travel, it also opens up so many doors for us to understand the universe. It was by thoroughly exploring this extreme phenomenon that we discovered relativity, understood the true nature of spacetime, and then unlocked the secrets of nuclear energy. This led to inventions like lasers, GPS, and MRI technologies that have changed modern civilization a lot. The speed of light is like a giant mirror hanging in the edge of the universe. We keep trying to understand it and go beyond it, which means we keep thinking about where we fit into the universe and learning more and more. By 2024, China's FAST telescope and the USS James Webb Space Telescope were working together to look at things in space. They were trying to see into the deepest parts of space. At the moment, our technology for moving around in space doesn't let us leave the solar system. But our eyes have already seen a little bit of light from 13 billion light-years away. Our minds have gone beyond space and time, reaching the very edge of the universe's birth. People have always been more interested in exploring new places than in traveling long distances. For the last 200 years, we have been getting better and better at measuring things. This has helped us to understand the universe better. Maybe the speed of light really is an unchangeable limit that humans can never get past. Maybe ideas about wormholes and warp drives will always be in science fiction. But this will not stop us from carrying on thinking about and trying to understand the unknown. Every time we study light speed, we learn a little more about the truth. Today, we think that every theory is impossible, but one day these theories might become real and change the world. Just as our ancestors a century ago could never have imagined humans walking on the moon, and scientists 50 years ago dared not imagine capturing actual images of black holes. Who's to say that descendants 100 years from now won't discover some amazing way to get around the speed of light? The universe is so big that it has given us a huge place to explore. It is so big that it will keep humanity busy for millions of years. On this long journey, we will keep on changing and technology will keep on breaking new ground. Maybe one day we will really find ways to travel through space and time. Or maybe we will meet aliens from another planet who are also trying to understand how fast light can travel. But no matter what happens, the search for light speed, which has been going on for hundreds of years, is already one of the most amazing stories in the universe. We are not prisoners on this planet. We are explorers who are curious about the world. The speed of light is not a final destination for us, but a starting point with endless possibilities. The speed of light is not just a universal speed limit, it's the basis of how time works and the laws of causality. For 200,000 years, the sunlight tried to escape from the sun's core. And right now, each one of us is racing through space and time without even realizing it. And the speed of light keeps the universe in order, but in a very strict way. It teaches us that while our physical bodies are bound by the laws of physics, our minds can go beyond these limits to understand the basic nature of everything. After reading this detailed look at the speed of light and cosmic laws, if you find this new way of thinking which completely changes how we understand these things inspiring, please show your support with a like. What are your thoughts on whether the speed of light limit is a protective mechanism or a prison for the universe? Please share your ideas in the comments. We'd love to discuss them together. If you're interested in more detailed science content about space and new physics, please subscribe to my channel. I'll carry on explaining the amazing facts about space and time to you. See you again soon.